introduction. So, myself, Snehanjan Acharyya. I'm a postdoctoral fellow at Indian Institute of Technology, Bombay, from India. The presentation I'm going to deliver is on the topic Gas Sensing Kinetic Analysis, a theoretical approach towards multiple gas discrimination. The co-authors of the papers are Professor Prasanta Kumar Guha and Professor Soumyo Mukherji. So the outline of the presentation includes introduction of the gas means why we need gas sensors, the sensing material that we have utilized for our work, then the sensor devices, how they look, and what are the sensing setup that we have used for the measurements. Then we will come to I will come to the results, the gas sensing results, and then I will move to the theory behind the gas sensing kinetic analysis and what the kinetic parameters that we have derived, and that will eventually help us to discriminate among the gases or volatile organic compounds. So on a daily basis, we frequently encounter both toxic and flammable gases around us, and depending on the field of activity, different gases might affect our health and well-being. So proper and accurate detection of these gases and volatile organic compounds is of prime importance. So you will find different types of application for gas sensor like environmental monitoring, medical diagnosis, agriculture, food quality, public security, industrial production, aerospace, and nowadays smart home is also a focus area. So different sensing methods are there. So we have utilized chemi-resistive one as it is very low cost, simple, economic, and have a easy chip level integration. So we have utilized metal oxide based that is sensors that is particularly tin oxide hollow sphere based structures that were further modified with metal nanoparticles including silver, gold, palladium, and platinum. So these hollow spheres were obtained using hydrothermal method, that is a chemical route, and these sensing material were further utilized to make the sensor array, and which was used for the measurement of the volatile organic compounds. So this is how this is the optical image of the sensor devices. So the platform used was interdigitated electrodes, IDEs. So these were gold-based interdigitated electrodes. On top of that, these hollow spheres were immobilized using precise amount of uniform suspension that was made using this sensing material. And this is a schematic of the gas sensing setup where we have utilized mass flow controllers, which was further combined using a mixer, and the gas was passed into the sensing chamber having a heater arrangement, which was controlled using a temperature controller, and the electrical measurements were done using a source measure unit. So coming to the gas sensing results, as we have incorporated 4 types of sensors, a sensor array, the different combination of responses was observed, including these sensors. So we have tested with 7 types of VOCs, that is benzene, acetone, toluene, propanol, formaldehyde, methanol, and ethanol. So each of the sensor was giving us some pattern in terms of response magnitude, but it is very difficult to perceive in a human perspective, like how to distinguish between among these gases. And this is for a fixed concentration, 200 ppm. So for that matter, we moved on to theoretical approach. And this is on the right-hand side, the figure illustrates the transient response pattern that we have obtained for different concentration. And this is the normalized, the y-axis represents the normalized response graph. Ig is the current in presence of gas, and Ia is the current in presence of ambient air. So this is a baseline resistance. As soon as we turn on the gas, there is an instantaneous increase in the response. It eventually saturates, and as we turn off the gas, it falls down, means it recovers completely to the baseline. So these transient pattern was further utilized to extract the kinetic parameters that I will move into using the different surface dependent factors and gas dependent factors that are very crucial for the kinetic analysis. So we can extract these gas dependent factors for the discrimination like activation energy, time constants, reactivity, reaction rate, surface coverage, and this will eventually help us to discriminate among the gases, because each of the gas is having different different value of these factors. So we have employed Ellie-Riedel model where The substrate is initially in presence of oxygen, the oxygen molecules adsorb on the top of surface and extract electrons from the surface. And later, when the VOC comes into the exposure of the sensor surface, the VOCs and get adsorbed oxygen make reaction that is depending on the kinetic rate constant, make oxidized products, and again donates electron to the sensor surface. So this way, the conductivity changes of the sensing surface, and we can utilize this thing for the development of the model. So if we consider like N0 is the total total absorption site, and N1 T is the occupied site density at time T, then we can formulate this kind of equation where the Ka is the active adsorption kinetic adsorption rate constant, and Kr is the kinetic rate constant of the VOC that is exposed on the surface, sensing surface. Now further formulating these and deriving the equation, we can get into the equation number 5, where this is a equation that is a surface coverage at a given time T. Now, if we can make, so this is the conductance change depending on the surface coverage, which depends on the adsorption-desorption process, and this equation was utilized for fitting of this transient response. So this green line represents the transient response, and tau response was extracted from this fitting curve. And this equation number 11, were further utilized to make the to extract the parameters. Now, for metal oxide-based sensors, this is a very well-known equation that is following the power law semiconductor equation, and the sensitivity of all the VOCs for all the sensors were extracted, and which is showing different sensitivity for different gases for a particular sensor. So these factors can be utilized for discriminations. Similarly, activation energy was further calculated using the equation that is involving tau response value and the log of this, the slope of the plots gives us the activation energy. And next, again, kinetic rate constant was was further calculated using the, using this equation, where kinetic rate constant was calculated. And so these kinetic parameters were calculated, and all of them are giving us different values depending on the gas as well as the sensing material. So if we summarize these kinetic parameters, this gives us all different values for different VOCs and different sensors. So if we can further do a PCA on this, that is a principal component analysis, so we can give some isolated clusters of these VOCs, and also it can be further utilized as a data set for the machine learning part as well. So if we want to get into a more real-time scenario, then we can do some more measurements, and so this will eventually assist us in discrimination of all the VOCs. Yeah. Thank you.